Okay, we're going to look at clustering now, and there are two main types of clustering that we're going to look at: hierarchical clustering and k-means clustering. Hierarchical clustering, what you do is you look at the pairs of the instances, and you choose and cluster together the two closest, and then you do that again and again and again, sort of clustering the clusters. With k-means, you take k centroids and you look at the things that are the closest, and then you do that again and again and again. So let's look at each one of these. So we're going to use this utilities database, which has a bunch of information on utilities demand in the United States. This is a very small data set, but it has things like cost, load factor, etc. And we're going to see which ones of them are similar to each other. Okay. So the first thing we're going to do is we're going to compute the Euclidean distance, just so that you can see how that's done. But one thing that's very important to do is to scale. Since we're taking distances, if we don't scale, normalize all of the variables, then some of them will overwhelm others. Okay? And so you can see that this is what it looks like when we z-score scale them. Okay, so now we're only using sales and fuel cost. We're going to go ahead and then we're going to plot this beautiful diagram that is called the dendrogram. And so the way to read this is that down here on the x-axis, the things that come together are the closest to each other. So for example, New England and United are close to each other, and Madison and Northern are close to each other. Whereas things that combine very late, for example, say Southern and Kentucky, are farther away from each other. And so here we have our first clustering, and we're using various distance metrics just so that you see how they work. And there's no right or wrong answer, right? Remember that the whole point of clustering is that we don't know the why, right? We know the input, we don't know the output. And so we will decide on what the best clustering is according to our business understanding. And then we can validate these clusters. Here we show the cluster on the y-axis. And you can see, for example, that Puget and Idaho are close together. So using the heat map, all of these values, or most of these values, should be close together. Whereas something that is far apart, say Puget and Oklahoma, which don't combine together till the very top, are very far. Like, this one's light, this one's dark, this one's dark, this one's light. Okay, so that's one set of clustering. Now we're going to look at k-means clustering. And here we're going to do it with a k equals 6. And here are the clusters. So Commonwealth is in 1, Madison is 1, Northern is 1, Wisconsin is 1. And you can actually compare it to this clustering over here. You could do that by hand, right? And so you could see whether or not those two clusterings are similar or different. Okay, and now what we're going to do is we're going to create what's called an elbow plot. And an elbow plot lets us choose what is the best number of clusters. And basically we go down here, and when it stops going down quickly, then we say, okay, that's the elbow. So here, probably 3 or 4 would be a good elbow plot. All right, so that's it for